Now that you've learned how to draw graphs of quadratic functions using a table of values, we're going to learn what we call the shortcut method. It's a different way of doing things. I'm never going to ask you to do it this way. It's just an optional thing. So if you're feeling comfortable with the table of values, that's okay, stick with it. But at least take a quick look at this video to see what you might be missing. For those of you that do decide to work with it, it is much faster. It just requires a little bit more thought. So let's see what it looks like. To start, the shortcut method relies on the very basic graph of y equals x squared. It's the most basic quadratic function we can have. There's no a value, there's no p value, there's no q value. It's just x squared. So if we decide to make a table of values for this function, we're just going to go around the middle of the graph. So 0 squared, if we're plugging it into our function, is 0. 1 squared is 1, 2 squared is 4, and then negative 1 squared, so remember that's negative 1 times negative 1 is positive 1, and negative 2 squared is negative 2 times negative 2, which is positive 4. So our y equals x squared ends up looking, if we draw a graph, something like this. We got 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. And let's just put a little bit more detail on our graph here. And so every time we draw a graph using the shortcut method, it's always going to go back to this graph of y equals x squared. So it looks something like this. We're going to use those points for everything else. We're going to do what we call transforming them, where basically we're going to take this graph and we're going to move it around, we're going to stretch it one way or another, and we're just going to see how things change. So thinking back to when you were using Desmos, if you changed A, remember that the graph would get skinnier or wider, or it might flip upside down. If you changed P, the graph might move left and right, but the shape wouldn't change. And if you moved Q, the graph might go up and down, but again, the shape wouldn't change. So we're going to basically use those principles to draw ourselves some graphs. It all comes down again to these numbers. So if we have 0, 0, which is this point up here, to get to our next point, we go over 1, and we go up 1, right? 1 squared is 1. Again, from the vertex, from 0, 0, to get to our second point, we go over 2, and we go up 4, because 2 squared is 4. So coming back down here, we're going to use those patterns. So we had 1 and 1, and we had 2 and 4. We don't really need to draw these to scale, but it's just helpful to illustrate the point right now. And then we also, if we kept going, we'd have 3 and 9, we'd have 4 and 16, because again, we're just squaring this horizontal value to get the vertical value. So 2 squared gets us 4, 3 squared gets us 9, and so on and so forth. So if we're drawing with the shortcut method, here's what we're going to do. We're still going to use the vertex the same way we did in the last video. So that part hasn't changed. So to start, step 1 is still place your vertex. So let's get ourselves a function. We'll go with the same one that we graphed first in the last video, which was y equals 2 times x minus 2 squared. Oh, that didn't come up quite right. Sorry about that. Try it again. So we've got y equals 2 times x minus 2 squared minus 1. So if we want to graph this, we found out that our vertex was at 2 and -1. So let's get ourselves a graph, and then we'll work with that. All right, so here we are. We've got ourselves a graph. Fill in some information. And so we're not going to make a table of values this time because we don't actually need to. If you understand this method and you know how to do it quickly, you can actually just skip straight to drawing your graph, which can save you a lot of time. All right, so we've got our graph. Our vertex was at 2, -1. So that's P and that's Q dealt with. The only thing that's going to affect our graph at this point is actually just that 2 out front. And so if we were dealing with a graph that didn't have an a value, we would actually have this exact same shape as we did for y equals x squared. So going back down here, we would have over 1 and up 1, over 1 and up 2, and so on and so forth. But in this case, because our a value is 2, all those vertical distances have changed. So instead of going over 1 and up 1, we're going to go over 1, and we're going to multiply that vertical value by a. So we're going to go over 1, and we're going to go up 2. So what's happening here is we take our y equals x squared pattern, which was 1 and 1, and 2 and 4, and we multiply only the vertical distances by a. So since our a value is 2 here, those vertical distances get multiplied by 2. So over 1 up 1, and then over 2 from the vertex. And so instead of going up 4, we're going to go up 8. So we end up all the way up here at 7. Now we reflect those points onto the other side to get our mirrored versions, and there we go. We have our 5 points. We didn't have to do any serious calculations. We didn't have to make a table of values. We just followed some patterns, and we got ourselves a parabola. And so we can see this if we go back to Desmos. So I'm just going to switch screens here. So let's try graphing it the same way that you did when you were dealing with your activity the other day. So we got y equals a times x minus p squared and minus q. Get our sliders. And so looking at our graph, let's set p and q to be 0 for now. This is that same y equals x squared graph I just mentioned. And so if we set our vertex to be what we found it to be, which was 2 and 1, or rather -1, you can see the graph right now. Pardon me, I put minus q instead of plus q at the end here. There we go. All right, you can see our graph right now follows that same general pattern where we've got over 1 and up 1, we've got over 2 and up 4, all from our vertex. So we've got this point right here, which is 2, -1. We go over 1 and up 1 to get to this point, which is 3 and 0, over 2 and up 4 to get this point up here, and so on and so forth. But if our a value changes to 2, you'd see the graph starts to go up a little faster, and suddenly those vertical distances have changed. So now, when we go over 1, instead of being at 0, we're now at 1. If we go over 2, we're now all the way up here at 7. You never have to use this method to draw your graphs, but it's just a faster way to do things if you're feeling comfortable with it. If you're not sure, feel free to get in touch. I'm happy to go through it with you a little more closely. But if you don't understand it, that's fine. Feel free to stick with the table of values.